Okay, let's complete the portion. Let us quickly complete it because I think this portion is very short and a lot of time is being taken. So till coefficient of restitution, we have done it. Now, elastic collision in one dimension. We are studying, we have to study elastic collision in one dimensions. Now, see, just tell one thing. When collision occurs, we have talked that momentum remains conserved. Correct. That's what we have studied, that momentum remains conserved. So if momentum is conserved, Jesslyn, can you tell me what should be written here in PI? Total initial momentum will be? See, Jesslyn, initial moment. Okay, you have answered. Yeah, Jesslyn, momentum is equal to mass into velocity. What is the initial momentum before collision? What do you see? Masses are written, velocities are written. Answer, Jesslyn. Jesslyn, unmute yourself and answer. Open the cameras, everyone. Open the cameras. Twice, you people, some people are doing this twice. I understand Jobita was not there in the class. For Abir, it's new. For Ali is new. But students who have had the class, who are having their revision portion, if you aren't answering this, then I'll have to arrange one third time. See, initial momentum. Everyone open the camera. M1 U1 plus M2 U2. That's it. MV is correct. Jesslyn, your this answer, this portion was right. But see, what has to be substituted? That is also equally important. M1 U1 plus M2 U2. Now for final momentum, we have M1 V1 plus M2 V2. Okay. So P momentum initial is equal to final momentum. So if we just substitute things here, let's just shift one terms here, M1 minus M1 V1 here. Oh, sorry, U1 is there. We have M1 here, M2, V2. So two term, we are bringing it together, and one terms we are bringing it together. So M1 U1 minus M1 V1 is equal to M2 V2 minus M2 U2. So if we take M1 common, U minus U1 minus V1 is left, M2 V2 minus U2 is left. Now, you know that kinetic energy is also conserved. So see, initial kinetic energy is also equal to final kinetic energy. So half M1 U1 square plus half M2 U2 square. So what is this class? Mass multiplied to velocity. See, half mv square. Are we justifying this formula? Half m1 v1 square. So what's the initial velocity right now? It's u1. So it becomes u1 square plus half m2 u2 square is equal to, what's the final case? Half m1 v1 square plus half m2 v2 square. So till this portion, you all should be able to write these two things. Kinetic energy conservation and momentum conservation should be written by you. You should be able to write both of these. How you have to write? If there's a modification, see class, this is not just about the derivation or anything. See, why are we studying this? If you have collision with you, class, how will you do? If there's a modification, if M1 is twice of M2, that is 2M2. Initial velocity is thrice of initial velocity of the second one. Like the something equation is there. The change will be in your this equation which you are writing. All the change will be in this equation only. Do you get it? So this writing portion, you should be able to write it by yourself. If you're not able to write it, it means there's a lack in your concepts. So this portion, please, everyone, if still there is any doubt, you can let me know. I'll clarify it. Now what we are doing it, half, half, half will be cancelled. Do not write down anything, just pay attention here, class. Everyone open the video cameras. Please open the cameras. So what are we left with? M1 U1 square plus M2 U2 square. This is equal to M1 V1 square plus M2 V2 square. So this is our equation. Again, we will interchange. M1 U1, M2 U2, all the terms will be interchanged. So see, when we are interchanging, M1 will be taken. This is the same step which we are following, which we were doing it in the momentum. Mass is taken common, so we are left with U1 square minus V1 square is equal to M2 multiplied to V2 square minus U2 square. Clear, class? We have two equations now. First equation, U1 minus V1, this is our first equation, which we have obtained as a result of momentum conservation. These steps I'm again telling you should know how to write. If there is any doubt in this, you should tell me right now only. I'll clarify it. And these steps also. Now these are taken common. So what we'll do, this is the second equation. This cannot be simplified further, and the first equation cannot be simplified further. So you take the ratio. Now what we'll do? We'll use the identity. What is the identity that we'll use? A square minus B square is equal to. This, Alina, Aftab, you answer. What is this identity? Alina, Aftab, I'm asking you, what's this identity? A square minus B square. I think answer is already written. You can answer this. Ali?
Ma'am, can you hear me?
Yeah, Alina, say. Yes, Alina, answer.
Ma'am, the answer is A plus B and A minus B.
A minus B. This much time shouldn't have been taken. I don't know whether you were searching or not, but this is the identity which you people.
Actually, I joined late.
Okay, but I am asking you this. This is not from the topic which we are doing, Alina. I have seen you joining it. I understand that. It's just that when I'm asking these easy questions and you know it. So it's answer quickly. And this instruction is not just for Alina, it's for everyone. You people take a lot of time, like this question we were doing before this momentum on Jesslyn. So Jesslyn, you knew the answer. If you do not know the answer, class, just simply say, I don't know. So that the class can be moved forward or the question can be passed. Okay. This is just I'm saying because then a lot of time is taken. So yes, Alina is correct. A plus B into A minus B. So this will be U1 plus V1 into U1 minus V1. Same thing here. So these two will be cut. These two will be cut. We are left with U1 plus V1 is equal to V2 plus U2. So U1 minus U2 relative velocity of approach is equal to V2 minus V1 relative velocity of separation. Those who have this written, they need not write it. And these are the two formulas which you should remember, especially Alina, Abir, and Jovita. Jovita, you were absent in the whole chapter.
Yes, ma'am.
Okay. So you also should have this. Okay. So, yeah, this formula you all should remember. Formula is U1 m1 minus m2 plus 2m2 u2 divided by m1 plus m2. Now, when you are calculating the velocity of the second body, wherever there is 1, replace 1 with 2, and wherever there is 2, replace it with 1. So u2 m2 minus m1 plus 2 m1 u1 by m1 plus m2, like this for both the bodies, for the first body, for the second body. These two formulas should be there with you. We'll see the solution of this question then. Quickly write down all this, those who have not written, and keep on updating me so that we can move forward.
Ma'am, can you scroll the
Okay, let's see the question which we have. See, here you have 2 kg mass with 5 meter per second and 4 kg with 2 meter per second. It's just that the direction is opposite. So predict the outcome of collision, assuming it to be elastic. So what exactly is happening? We have the masses available and we have the formula of velocity too. So you know what's the formula of the velocity? Already you know it, right? So same thing we are going to do. Basically, you have to put the values. So see, these two formulas which we have studied, u1 m1 minus m2 plus m2 u2, one only I'm writing, the other you will predict it, you will write it. So this is u1 m1 minus m2 plus 2 m2 u2 by m1 plus m2. So see, what are the values? You know, here when you are calculating the final velocity, what's u1? u1 is 5 meter per second. We are taking the right as positive or the left? Yeah, right is positive. And m1 will be 2 kg. u2 will be minus 2 meter per second. And m2 will be 4 kg. Put all the values, get the values of v1 and okay, this you all can do. Let's come to see, when you will solve it, you will see v1 is the final velocity of 2 kg body, 13 by 2 meter per second towards left, and v2 will be the final. Basically, the answer is 13 by 2 and 8 by 3. So write this answer. I'll show you calculation part. I'm not doing it. You all will do it. Okay, certain special cases which we have to see. See, if M1 and M2 are equal to some mass M, which is identical. So M and M will be same, that this part will be 0. So you'll be left with 2 M2 U2 by 2M, because M and M will make 2M. So just the velocities will be interchanged. V1 will be equal to U2, and likewise, if you put the values for V2, you will get V2 equal to U1. This is the case. Second case, if M2 is very much greater than M1, so if M2 is very huge, it's very greater than M1. So this entire small block will not be able to move M2. See, if this, so smaller mass like lighter mass like M1 will not be able to push it. So this will approximately be equal to, would be equal to, am I audible, class?
Yes,
Yes.
ma'am.
Okay. Thank you, Jocelyn. Actually, when I leave, so any one of you will be the host right now. So if I join back, just make me the host, because then the entire recording and everything will be there in your system. So it will be difficult for us to manage. So because Learnivio is not here right now, they have not joined it. So that's why if only you all, any one of you will be the host. Yeah, I was saying we'll equate this to M2. So when you equate it to M2, U1 into M1 minus M2 plus 2 M2 U2 divided by M1 plus M2. So U1 will be equal to M2 by M2 and that will be cancelled. Straight away you will get 0. So V1 will be directly equal to U1. V2 will be equal to U2. Yes, first special case, this one. See, both the bodies are identical. When the bodies are identical, U1 into M minus M, where it was M1 minus M2, here we'll just have M minus M plus 2 M2 U2 divided by 2 M1 plus M2. Now, M1 and M2, there is no concept of M1 and M2 here. So what will happen? Straight away, we will have 2M. Instead of the concept, we'll have it as 2M. Okay. So this will be 0. So U1 into 0 is 0. This term gone. We are left with 2M U2. Because if we write M2 and if we write M, that's the same. 2M U2 divided by 2M. 2M cancel. V1 is equal to U2. Similar calculation you will perform. So V2 will be equal to U1. V1 is equal to U1. Okay, this we have discussed. Okay, last case. If the opposite happens, if M1 is greater, same thing, V1 will be equal to U1, V2 will be equal to 2U1. You can put the values in the formula and check also right now. All the students. Start writing from here. Okay, let's come to inelastic collision in 1D. So M1 U1, M2 U2, M1 M1, and MV1 M2 V2. These are the same things which we have when we are discussing inelastic collision in 1D. See, M1 U1 plus M2 U2, same thing. Momentum conservation, same equation. In perfectly inelastic collision, bodies have the same final velocity, they stick to each other and move with a common velocity. So instead, what will be the change? Instead of V1 and V2 separately, we'll have one common single capital V as the velocity. Okay. So what will be the formula for this capital V common final velocity? M1 U1 plus M2 U2 divided by M1 plus M2. And loss of kinetic energy you can calculate by delta K, that is initial kinetic energy minus final kinetic energy. Okay, and this is a question. 2 kg, same thing, same question, but it's just that the direction is same. And final velocity you have to find out. It's a case of perfectly inelastic because the same velocity is there and the bodies have stick to each other. So V is equal to M1 U1 plus M2 U2 divided by M1 plus M2. I'll show you the solution, but at least first write it down. This is from the class notes only. Write down this class. This completes with this. We'll start with collision today. We'll start with center of mass today itself. Okay, Abhi, let's see. 16 by 5 per second. Okay, correct. 16 by 5 meter per second minutes. Last elastic collision is in 2D is left. 2D is very simple. You just have to perform the resolution of vectors. So M1, M2, these are present with the velocities. Now velocities in 2 dimension, they are inclined at certain angle. You will perform the resolution of vectors. See, if this is V1 cos theta is there on the x-axis and V1 sine theta on the y-axis. Then V2 is here. Why it is happening? See, both the bodies have collided. And is it possible that after every collision, both the bodies will continue to move in a straight line only? No, that is not a fixed case. If that happens, we call it as collision in 1D. But if they move in different directions, subtending certain angles, that angle can be calculated. So if they move in random directions, most common question that comes is when the total angle between these is 90 degree and the net velocity is asked. So you just use under root V1 square plus V2 square as your parallelogram, or write it somewhere so that you remember when you are revising it. That most of the time V1 and V2 have the angles 90 degree between them. So resultant is under root V1 square plus V2 square. Elastic collision in 2D. So if the angle is there, then we say it is in 2 dimension. Same thing, conservation of momentum along x-axis. But in x-axis now, instead of V1 and V2, you will be considering V1 cos theta and V2 cos theta. Clear class? Like this, you will be considering V1 cos theta and V2 cos theta. And in case of y-axis, see, I'll show you. Look, x-axis, m1 u1 plus m2 u2, no angle, no theta. Why no angle? Because they have just begun to move and they are moving in a straight line. So there is no concept of angle here. m1 v1 cos theta 1 plus m2 v2 cos theta 2 is there. Then y-axis is there. So u0 is equal to m1 v1 sine theta minus m2 v2 sine theta 2. Theta 1 and theta 2 can be same also, class, because in the exam what I have observed is that 2D is asked rarely. And even if they're asking you the thing which I mentioned, that the angle between them, they'll make it as 90 degrees. So that answer is very easy. Or theta 1 and theta 2, they make it same. So do not go into the depth. Just remember, even if the angles are different, you can calculate sine theta 1 minus sine theta 2. This one, so kinetic energy conserved. Here, kinetic energy is conserved. Okay, so when you are writing kinetic energy conserved, same thing. Then you write the values. Now see, when you are writing kinetic energy conserved, in kinetic energy, you need not mention V1 cos theta, V2 cos theta. Can anyone tell me the reason? Why have I written it like this, and whereas I have written it like this? I have included theta and all the resolution of vectors in the momentum portion, but I have not included any resolution of vectors in kinetic energy. Can anyone answer this? The logic is very simple, class. Anyone? Why is the resolution of vectors being included in the first one, whereas it's not included in the second one? If your basics are right, you'll be able to manage. No, not conserved. Momentum is also conserved. It's not related to conservation. Anyone else? Or any other answer by you only? Think resolution of vectors related with something. It's a scalar quantity. Correct answer, Sham. It's a scalar quantity, class. Momentum is a vector. We need resolution of vectors. But in kinetic energy, why will you resolve vectors? You have V1, you have V2. That's enough for kinetic energy. Whether the velocity is going in the north direction or northeast direction, that's none of our concern. We just require velocity for kinetic energy, and that is mentioned. Okay. So just mention that also when you are writing in your language. Just mention it somewhere. Start writing from here. Those who have not got the answer, write it. One student only got the correct answer, who was Abir. Abir has got the right answer for this. Okay, see class, just a brief about this chapter. Here in this, I think time is not left. Let's complete it tomorrow only. Let's start this. The notes are here only. It will be a revision for some students and for many